Steroids. Dominic, thank you.
Okay, oh good, I'm very amplified. Right, so hello, I'm Dominic Fox. I'm a senior consultant at Open Credo. We're a kind of consultancy. We do big data-ish things, lots of cloud and Kubernetes and Cassandra and stuff like that. And I'm the developer of Concursus, which is an open source framework for building distributed event sourcing applications. I'm a Java developer mainly, a bit of a Haskell hobbyist, and a fairly new Kotlin enthusiast. I've got my email address there, and you can follow me on Twitter as I'm Dynamic Proxy. Tonight I'm going to be talking about how I've used some of the language features of Kotlin to build an API around the core of Concursus to facilitate generating and handling events, and to enable me to explore further some of the similarities between the event sourcing model and a stateful processing model based on access and state machines. So I'm a greedy early adopter. If I see that a language has lots of nice new features, lots of nice syntax sugar, I want to use all of it at once. And later on, you sober up a bit and you think about how other users of your code maybe need to understand what's going on, and maybe you didn't absolutely have to introduce a monoid type class just to do string concatenation. And I'm genuinely sorry to everybody who's had to work with the Scala code I wrote in the first 6 months of learning the language. The code I'm going to show you today has a bit of an everything but the kitchen sink quality to it as far as language features are concerned. But Kotlin is a pragmatic language. It's a language designed above all to make developers more productive. It's possible, as Nat was showing earlier, to go a bit over the top with it. So it's useful to think about where to draw the line in terms of introducing magic into an API. So I hope this presentation sparks a few ideas, but I'm also not unequivocally recommending that you emulate everything that I've done here. Keep a critical perspective, keep a pragmatic perspective, and think about your users. So Concursus has a core domain model which is basically concerned with saying what an event is and providing some abstractions for generating and routing and persisting and replaying and handling events. So an event is something that happens to some entity, which we call an aggregate for sort of domain-driven design-related reasons. So there's its identity, aggregate ID of it's a person, that's the kind of thing it is, that's its ID. It happens at some particular time, and we have a concept of a stream timestamp, which is a combination of a millisecond instance and also something that identifies a stream of events, so we can disambiguate events coming from different sources that maybe have kind of colliding timestamps. And if you order the events that have occurred to an aggregate by time, you get that aggregate's event history. The other thing is we've got the name of the event, so something was created, and maybe some attributes associated with it. So a person was created with a name and an age. For some reason, for years now, the person's always been Arthur Putey. So the fundamental idea in event sourcing is that an aggregate's status at any given moment is a function of its event history up to that moment. So, for example, let's say our aggregate's a parcel, and we're tracking the delivery of that parcel. It can be received at a depot, it can be loaded onto a lorry and delivered, or the delivery can be missed because there's no one there to receive it, in which case it may go back to another depot and you might retry. At any given moment, the aggregate state can be described with 3 variables. Where is it now? How many times have we tried to deliver it? And has it been delivered yet? And each event that can occur to it will modify this state in some way. So Concursus provides a Java 8 mapping for its event model, in which an aggregate type is represented by a Java interface, and the events that can occur to it are represented by methods on that interface. And there's a bit of a convention. They all return void. They, by convention, have 2 parameters to start with, which is the timestamp and the ID of the thing that the event occurred to. And then any remaining parameters are the attributes of the event. And we know the event name and the aggregate name by kind of reflecting over this interface. You can kind of add annotations and so on if you need to give more, if you need to change the mappings of names and stuff like that. So In order to generate a parcel event, you obtain an object, which is a Java 8 dynamic proxy, which implements this interface, and it translates method calls on this interface into Concursus events and then passes them to a consumer, which will do something with them. And that looks like this. We've got a consumer of event called event writer. As simple as possible consumer, it takes it and just prints it out to the console. We create a proxy, which proxies to this event writer using the parcel events class, and that gets us an instance of parcel events that we can call methods on. And on that proxy, we say, OK, received at depot, we give it a timestamp and ID and the name of the depot, and it spits this out to the console, which is a representation of the event data. So what kind of thing did it happen to? What was the ID? What was the event? When did it happen? And also we've got a little bit of associated data. And that then can be kind of pushed into a Kafka stream or written to Cassandra or whatever else we then need to do to it in our event system. There's also an event bus interface which abstracts this just a little further and lets you batch multiple events up to be processed together. So if you've got an event bus to hand, say dispatch, again you give it the name of the class, and then it gives you a batch object, and you've got a little lambda, and you can send out multiple events at once. It's kind of handy if you want to treat several events as a kind of transactionally and run them all together. You can also have the bus use a dispatch async method that will return a completable future, so you can kind of do this asynchronously and be notified when all events have been processed and things like that. Handling events uses the same mechanism in reverse. If you want to handle events for a parcel, you implement the interface, and you get an event store to replay the events for a particular aggregate by calling methods on your handler. So here's one for parcel events, which updates the current state of a parcel. Those are the three state variables. It's got a current location, a count of delivery attempts, and a Boolean to say whether we've delivered it or not. And each method is going to modify that a bit. It might change the location, it might change the state of the delivered flag, it might increment the number of delivery events. And once we've got one of those in hand, we can replay the events from some event source into this handler. So we get something called a dispatching event source that knows how to take events from some event source and translate them into method calls against the parcel events interface. We dispatch it to our handler, and when we replay it, we can then, at the end, ask our handler how many delivery attempts were made on this particular aggregate. So that's the Java 8 mapping. In between dispatching events and replaying and handling them, event objects generated by method calls can be routed through various filters, published to other handlers, written out to logs and message queues, and so on. And the internal representation of an event is a bundle of event metadata plus a little typed tuple of event attributes, which can be inspected and modified. So if we've got an event in hand, we can actually kind of ask for its attributes and parameters and do things with it. So we don't have to use the kind of method mapping interface to do things with events, but it makes it nicer. So the basic idea here is that we have an API-neutral internal representation of events, the actual event class, but this can be mapped into method calls, as per the Java 8 API I've just shown you, or you could map them into POJOs, or whatever else you like, which brings us to Kotlin. So the motivation for designing a Java 8 API based around method calls is basically that I think POJOs as value types are a horrific blight on Java. And being able to define the complete protocol, the complete set of events for an aggregates type in a single interface is really appealing, as is being able to use the same interface to emit and receive events. The event as method call metaphor is one that I like, because it suggests a semantics in which events are verby things, things that happen, rather than nouny things. So the Java 8 API for Concursus nounifies verbs. It turns method calls into event objects, and then it reverbifies them at the receiving end. It turns an event object back into a method call. And this metaphor meshes pretty well with a stream processing-oriented point of view. In Kotlin, though, we have a much more concise syntax for declaring classes that basically function as value types. And that shift in affordances changes my preferences. So here's the definition for parcel events using the Kotlin API. We have a sealed class, parcel events, and we have 4 subclasses of that class representing each of the 4 event types. and they all inherit from parcel event. The first thing to notice is that the parameters for timestamp and aggregate ID aren't included in the event class. So these classes just represent the different kinds of events and their associated attributes, but not the event metadata, so not the aggregate ID and not the timestamp. Those things are added in later. The second thing to notice is that the relationship between events and an aggregate type is mapped onto the relationship between the sealed superclass and the fixed collection of subclasses. So our definition of an event protocol in Kotlin has the same shape as the interface and method-based definition in the Java 8 API. It's more concise. We've got rid of some extraneous detail, and we've reduced it really down to the fundamentals, which is a good start. We've also changed metaphor in an interesting way, I think. Events are nouns again here, but they're a finite set of nouns organized according to a taxonomy, a bit like the members of an enum. A parcel event comes in one of 4 and only 4 flavors, and each flavor has a distinct signature defining what attributes can be associated with it. So I gave this talk the title Enums on Steroids to give a sense of what it feels like to use sealed classes here. And one really important aspect of this is the intelligence that an IDE and a compiler can bring to code that handles instances of the sealed class. So suppose we have a plain old Java enum and a switch statement that uses it. So our enum's just got our 4 event types. And we've got a method called handle event that will take the event type and then, let's say, a mapper string to object, which has got some event data. We can switch on the event type, and depending on which one it is, we can pick out the bit of data that we want from the event data and construct a suitable message describing the event. The IDE and the compiler can know that that switch statement is complete, as it handles all possible cases for a parcel event type. So we can be confident that the entire protocol for parcel events is covered by this statement. Now here's the Kotlin equivalent, using our sealed class and its subclasses to describe events. We use the when construct here. So the IDE and compiler can have the same intelligence about the possible subtypes of parcel events, because the class is sealed, we're not allowed to define other subclasses of it outside of its own scope. But now the event attributes are bundled together with the value, and they can be accessed in a typesafe way, because what the when statement does is, having identified that the event is the kind of thing on the left of the arrow, it then treats it as that thing on the right side of the arrow. It's basically kind of cast it to that thing on the right-hand side. So when we access depot ID, we know that we're accessing the depot ID of a received at depot event. So everything's much more type safe. We're not just kind of pulling things out of a map. The when statement also mirrors our use in the Java API of a class implementing an aggregate type. An aggregate type's event protocol describing interface to handle events. Again, it looks a bit like just having a method for each event. But again, it's if anything, cleaner and more concise. So sealed classes in Kotlin allow us to treat the event protocol of an aggregate type as an algebraic data type, an ADT. And this is one of the fundamental concepts of functional programming. I'm just going into a little more detail on this. Here's an ADT for a binary tree. So a binary tree, or a node of a binary tree, is either an empty node, nothing, a leaf node, which just contains a value, or it's a branch, which has got a left and right binary tree. It's a recursive data type. You can define the entire tree using this. And if we wanted to convert that into a list, we can write a function to do so. So we take in a binary tree, and we pattern match on it. What kind of thing is it? If it's an empty node, you get an empty list. If it's a leaf node, you get a singleton list, picking up the tree's value. If it's a branch, we turn the left tree into a list and the right tree into a list and concatenate them together. Making this tail recursive, I'm going to leave as an exercise for the reader. The rule here is that the constructors for each subclass of the sealed class build up values in the ADT, and destructors, the matches in the when clause, take them apart again and unfold the data into a new form. Now you may remember that I said earlier that in event sourcing, the state of an aggregate is a function of its event history. So if we treat events as values in an ADT, That allows us to construct them at the point where they're emitted as bundles of typed data, and deconstruct them at the point where they're consumed as transitions on a state machine, so that we can model the function that converts an event history into a current state as a functional fold over that event history. And here's what that looks like. So there's quite a bit to get our heads around here. The basic idea is that we model the state of the aggregate as a type, a Kotlin data class for convenience. So it's parcelstate, data class, and it's got three properties. Delivery attempts is delivered from current location, much as in our Java example earlier. We've also got a companion object here giving the possible transitions on the state, and I'll explain why it's in a companion object in a moment. So we have two functions, initial and next. Initial tells you how to get an initial state from the first events to arrive, and next tells you how to transition from one state to the next. And both of them pattern match on the inbound event type, so they fold the new event into the previous state, which acts as the accumulator in the fold to produce a new state. Basically, the reason we have to do this in a companion object and can't just define it as methods on parcelstate itself is that for initial, we don't have an instance of state. So we have to have something that we can call when we've not got a state yet to get us a state, and then something we can call when we have got a state to fold new events into it and to produce the subsequent states. And once we have this, we can generate the state of a parcel by using a run-all method, which is defined on transitions. And we just give it a list of events. So received at depot at a certain time, loaded onto truck at a certain time, and it will return us the state of the parcel based on that history. If this looks a bit like the way that actors handle inbound messages, and specifically this kind of pattern matching approach here, that's not a coincidence. What we've got here is a purely functional approach using immutable values to stateful event handling. And this allows us to express the state of an aggregate as a function of its event history by pattern matching on inbound events as they're replayed into a state transition model. It's a really clean and principled way of defining that transformation. You may have noticed that our events have now got timestamps attached to them using an @infix function. Yeah, I like infix functions as well. And this is defined as an extension method, because I like those too, on all types. So given any value, we can turn it into a timestamped value by calling on it. So we have something called timestamps data, which just contains a timestamp and some piece of data. And we have a function which, given a timestamp and our this object, where has it gone over there, will create a piece of timestamp data. So we also have a toInfix method on timestamp data, which allows us to supply the aggregate ID, so we can construct a complete k-event object, which basically has all of our data and metadata. We've then got our bundle of attributes, and we've got a timestamp, and we've got the aggregate ID, which is everything we need to define a complete event. Now, extension methods on any are something you should probably think carefully about introducing. They're kind of the nearest thing in Kotlin to Scala's implicits. And if that doesn't scare you, you've either spent too little time around Scala's implicits or too much. A method is magically added to all objects, but only if you've got the right import. Is that a good idea? Well, you can do this. There's a safer alternative, which is to add this method to some interface called event data, and have the sealed classes for your event protocols all implement that interface. So actually you're making a choice then to say, we're going to have this method on things of this type. What we lose if we do that is the ability to capture the type E of the object that we're calling the method on, because you see that we construct a timestamp data of E, and we know the type here. Here, the only way we can do that is by declaring the type parameter of event data and actually having an explicit cast here. So it's comparatively a bit clunky. So there's a bit of a trade-off here between a slightly discomforting level of implicitness and generality and a slightly clunky level of having to explicitly spell things out. And I leave it to your conscience which of those you prefer. I'm not going to get too deeply into the reflective magic that's used to convert are k-event objects in Kotlin back into Concursus events and back, except to say that Kotlin's reflection API is much saner and nicer than Java's, and the amount of code I had to write was considerably smaller. So instead, I'm going to finish up by talking briefly about the other ways that my Kotlin API uses extension methods, which I think are a superb mechanism for glomming Kotlin functionality onto existing Java APIs. So in the plain old Concursus API, there are classes like EventBus, which know how to handle plain old Concursus event objects. They don't know anything about the Kotlin API's k-events. In the Java 8 API, there are classes like proxying EventBus that wrap a plain old EventBus in order to expose the interface-based API that we've defined for Java 8. And that works fine, but it means you have to build up these wrapping layers before you can do anything. So you get an event bus, and then you wrap a proxying event bus around it. Or you've got an event source, and then you wrap a dispatching event source around it, and so on. And that's how you go from the kind of the innermost layer of the library to the kind of extended functionality. In the Kotlin API, we can simply bolt methods that handle k-events straight onto event bus and event source and fuse the Kotlin layer into the underlying layer without having to introduce wrapping classes. So we just create a method called dispatch2 on event bus, which allows us to supply an aggregate ID and it has the timestamp data, and it does all of the translation needed to convert that into a set of k-events and call a toEvent method on them that turns them into the underlying Concursus events and just send them all off to the Concursus batch. And that gives us then the ability to say event bus dispatch2, give the ID, and then just list out a set of events, which is a really nice, clean syntax. So in this way, the outer modules can progressively layer functionality into inner modules without having to introduce chains of wrapper classes. And this is a perfect fit for Concursus's modular design, where a core domain model is enriched by extension modules. And I think it's a cunning tactic for enabling developers to build very concise and friendly Kotlin API layers around crusty old Java libraries, of which there are so very many. An earlier version of the Kotlin API made use of receiver methods, receiver functions, but I realized I didn't need them, and the design was actually cleaner without them. So that's one language feature at least that I don't need to talk about this evening, but it's a very cool one, so you should definitely check it out. Okay, I have a few conclusions and recommendations based on the experience of building this API. The first is that Kotlin is simply a great language for API development, and it's got powerful language features for creating typesafe embedded DSL to many purposes. I think the approach of kind of layering extension methods and defining extension methods sort of locally to handle different cases is particularly nice for this. The second is that a change in the affordances of a language, so the kinds of things that it makes readily available to you, can mean a change in the metaphors you use to think about your code. And this isn't a kind of a question of paradigm in the kind of big sense of object-oriented versus functional. It's sort of more low-level and more fine-grained than that. It's a question of which patterns you employ to express the logical connections between things. Algebraic data types, expressed using sealed classes and pattern matching, aren't the new right way to do everything, but they do fit certain use cases in a very natural way. I think Kotlin isn't just a better Java. I think it's a more expressive language with room for a few more metaphors, a few more ideas about how to organize things. And it's really worth getting to know these, maybe even overusing them a bit experimentally until you get to know their limitations too. My final conclusion is that Kotlin has been designed to fit very naturally into the existing JVM ecosystem, and the extension methods in particular enable it to get hooks into all kinds of places where otherwise you'd be dealing with another clunky layer of abstraction. This is a really strategically smart piece of design, and I hope it's going to take over a large chunk of the JVM world. Okay, so I have to come up with a question. I do have a question. It's a really obscure one. You will notice here and there that I'm declaring my type parameter as a subtype of any. Why would I want to do that?
doing it that way, you've got power to form lots of type.
It's not quite that. It has to do with reflection. Basically, if we want to guarantee that our value is non-null, and if we want to be able to kind of do reflection over the class, we need to subclass any. So there are various things, and it's still slightly mysterious to me, but if you don't actually say that you're subclassing any, it hasn't got quite enough information to know that your value isn't null. Any is the type of a non-null value, and that has an effect on what you can do. Okay. In that case, I shall come up with a silly question instead. Who was Arthur Putey? Yeah. He's a Monty Python character. Brilliant. You win. Okay. Okay. So I guess we've probably got about 10 minutes, yeah?
Yeah, we got time for questions.
Yeah.
Anyone? Anyone at all? No, there we go. Is it about open?
No.
Okay.
Because most of the time I'm used to, putting read the logic to the class, and then it's more general question about, because if you're using data classes, you don't have really much logic there. So where do you put the logic? Because I don't want to end up with anemic model. Just I'm not maybe used to that functional programming style. Maybe what's your best practices to handle to keep that data together with the logic? Thank you.
I guess the assumption in this case is that we're in a slightly closed world, so we're not looking for the sorts of extensibility that you might be trying to achieve with a kind of a traditional object-oriented approach. What we're looking for is to kind of model the way in which you can transform an event history into the state of a thing at a particular moment in time, using a very finite set of possible transitions. We're basically defining a state machine. And so that's a thing where we kind of want to define it all together in one place. We're not really looking to kind of extend it arbitrarily in kind of remote locations. It's kind of good to be able to define it all together in the same place. One of the reasons, by the way, why it's quite nice to have this approach where we kind of make transitions where we're copying a data class and creating new instances, so we're always using immutable values, is that if we're doing things statefully, we might be routing events to sort of various things in the cluster, and having an immutable approach to updating the state of something, so taking an existing state and returning a new state without changing the value of the previous state, is very, very convenient when you've got kind of lots of concurrency going on. So it's a bit specialized to this particular case. Yeah, I'm certainly not suggesting that you should always pull apart what would have been a traditional kind of object-oriented model into data here and possible changes to it over there. It's a fit for this particular thing that we want to do, which is modeling state machines, rather than necessarily the right general approach.
Any other question?
Hi, I'm not familiar with these classes, so my question might be general, very general. So how do we handle versioning with SIL classes? So if the consumer, let's say the SIL classes are in a third-party jar, and our consumer is in our code base, and we upgrade the library, and someone introduces extra SIL classes, are we going to get a compilation error?
Yeah, if you cannot, outside of a sealed class, introduce new subclasses to it. That's kind of its contract, essentially. Which means that using a sealed class you don't control, you're always going to be kind of bound by its constraints. In the case of Concursus, the sealed class and its subclasses are defining a contract, and they're mapped onto an underlying kind of much more weakly typed model. So if something's been generating one set of data, but you want to extend that protocol, you can always create your own class with your own subclasses, because the important thing is the mapping of the class names and the subclass names into the underlying kind of event model. So you can produce multiple separate sealed classes representing different versions and produce events with one and then consume them with another. You're not actually, but that implies that you're doing a mapping into some kind of common language that they can both speak, which Concursus does.
Okay, thanks.
Hi. The code that you chose is actually really similar to Scala. And probably you could write that in Scala in a shorter way. Mm-hmm. Why did you choose Kotlin instead of Scala?
So, yeah, I mean, a lot of this stuff is very Scala flavored. I have some experience with Scala. I think it's a great language, but it's also a language which inexorably seems to pull people towards higher and higher degrees of complexity. When we first adopted Scala at Tim Group, where I used to work for, we tried to kind of impose some boundaries on how much complexity, developers adopting Scala were sort of forced to confront, and we tried to have some rules about how we were using it to sort of stop people from using the more sort of complex and difficult to grasp features. But every time you use a third-party library in Scala, it pulls you into that world kind of willy-nilly. I think Kotlin strikes a really nice balance between power and complexity. There are some things from Scala I miss in it. There's times when I actually think higher-kinded types would be really nice here. But if you give certain people higher-kinded types, what they do is they go away and they make Scala Z. And that's a fine thing to exist in its own world, but if that complexity comes to permeate your language, it's much harder to get people on board with it. And I think Kotlin, in a way, has quite sensibly restricted the scope of its complexity. It's a language which Java developers should be able to get on board with very quickly without feeling that the next step in complexity is the one that will take them off the cliff edge, where actually they need to go away and learn Haskell or something. It's never going to be a Haskell on the JVM or something that people that wish they had Haskell on the JVM will use. And I think Scala has always had a bit of that flavour to it. It's, in a way, it's a function of design. You can write, of course, Scala that's as simple as any Kotlin, but what's actually happened in the evolution of the language and its libraries and its communities isn't that. And I think that Kotlin has been designed so that the language and its libraries and its community will evolve in a different way to the way that Scalas have.
If I may, I would just like to add to that, because you had to bring up the question of why Kotlin and not Scala. And I think that a lot of times, like from a JetBrains perspective or so-called official perspective, we always say that if you are happy with Scala, then you have no need for Kotlin. But one of the comparisons that at least I try and do, is that in Kotlin we purposely restrict, like what Dominic was saying, we restrict what you can do. So many companies that are adopting Scala or use Scala have a kind of like a design guideline of what you should and what you shouldn't do in the Scala language at this X company. And what we try and do is kind of build that, restrict that into the language, so to speak, so that you don't have that additional need to have a design guideline, so, in a sense. Any other questions?
So, from your experience with sealed classes, have you found any limitations that prevented you from creating some extra functionality you wanted to?
There is one little limitation, and I know other people have talked about this before. The subclasses of a sealed class can't be data classes, and that's a real shame, because with data classes you get the equals and the hash code and the toString for free. And I think there's some thinking being done about under what circumstances data classes might be able to inherit. If they're able to inherit generally, it creates difficulties, but it would be really nice if for a sealed class they could actually at least inherit from that.
That's actually resolved in 1.1.
Hey,
So
there you go.
there you go. I love these questions. They're so easy. Brilliant.
I knew
When?
that was the answer.
Yeah, when? So the question, when is 1.1? It was originally estimated to be released around autumn this year, but we're now kind of looking at early next year. but the preview is there. M1, which is the first one of M1.1, was recently released. M2 is coming very, very soon, and it's going to have all of the fixes that 1.03 and 1.04 had as well in M1, 1.1 M2, milestone 2. Question?
Is there going to be a lot of syntax changes?
Question is?
You said 1.1's coming. Is it going to be like Swift where I have to rewrite everything?
No, it's not going to be like that. So we kind of try and guarantee as much as possible backwards compatibility and not any changes. And if you've been kind of using Kotlin through M0 up to the release, you've noticed that what we've tried to do always is, as we introduce any changes, we provide the quick fixes for you inside the IDE. So we kind of take it in a two-phase. The first phase is, this is going to be obsolete in the next release. And then in the next release, well, we offer you in the IDE the ability to kind of replace globally and upgrade your code. So given that we are developing the tool along with the language, we have that facility, right? And we try and do this. I don't know if you're aware that we also developed the Eclipse plugin for Kotlin. We've also recently released NetBeans support for Kotlin as well. So if you're using any of those IDEs, you'll have that. Any other questions? Did you ask the question to win a license?
I did ask the question, and I got an answer.
Excellent. So just give me your name later. So there was someone that won the license in the previous session. If you're still around, please also stay behind and give me your name. Otherwise, I want to thank you very much for coming tonight. I hope you enjoyed it. There will be recordings. We'll publish them soon. We'll probably follow up with everyone that was registered for tonight. And once again, thank you very much to all the speakers that gave their time to present tonight. So thank you very much.